There we go. Yeah, she's number 3. Cool. Renee is coming. Thank you, everyone. We're going live, so I'm trying to stay on time here, and people will welcome them in. And my name's Roger STRUKHOFF. I'm the conference chair, and even though we did not heavily promote this, I'm leading this sort of keynote panel today. It's not a normal panel. At first, I'm going to talk, and then I never get tired of talking, but once you get tired of hearing me, we're going to turn it over and I'm going to ask some questions from our panelists. And we have Gordon Half, Red Hat. He's going to serve as our resident overall cloud guru this morning. And Ed Featherston from CTP, which is an HPE company. He's going to serve as our resident DevOps guru this morning. And Renee Bostic from IBM, and she is for their comments on what I'm saying. And that said, the title of this is As We Were, As We Are, and As We May Be. I make reference to a famous document, famous article written in 1945 from a guy named Vannevar Bush from the US government. Forget the exact name of his office. And it was all about technology. In 1945, with the World War's over, he thought maybe we could actually do some good with the technology. So in that context, happy birthday to us. We started this show in 1994, 25 years ago. It's called Java Edge. I was talking yesterday to a person who's developed some really great new education. Was the big thing that enterprise IT people worried about, maybe not in that order. It might have been RAS first, I think. Local area networks were finally coming. Those of you who are really ancient like me will remember that 1984 was the year of the LAN. And it was the main one that emerged was Ethernet that Bob Metcalfe created, and Metcalfe's law, which was networks, it's exponential. The number of
the value of a network
increases exponentially
with the number of users.
Right, which can't exactly be explicitly, literally true, but close enough. And then WANs were big. We're going to have campus-wide networks, and we're going to have a WAN system, and remember Token Ring and all these wonderful things we're going to have. And the main thing was it was really slow and never worked, and was frustrated, and so SneakerNet was kind of the way we did things. Browsers were emerging. The Mosaic browser, Spyglass. Some people know the history better than I can't remember. What was Sun's? Sun had one. A lot of browsers, and we were getting this idea of hot Java? Thank you. And we could get this idea on what we call the worldwide weight, that you could get there and like all of this stuff would come out. It was a friend of mine that said, this is like the world's biggest hard drive, and you didn't even have to put the stuff on it, you know? And RDBMS, Relational Database Management Systems, there was a famous New Yorker cartoon, I remember, and there's a bossy-looking person standing over one of his minions saying, we need an RDBMS strategy, can you find out what that means. And that was the idea. But the idea of relational databases were coming. I worked with Bob Epstein at Sybase for a while. He was one of the pioneers, and before that, there were pioneers before him. And it actually turns out that creating a relational database is pretty hard. It was because it was like a third body motion problem, really difficult, and with multiple people accessing, and there were some really serious problems that they had to solve back then. And then there was this open source, this subversive open source, and the copylefts and all this stuff, and the distinction between free speech and free beer had not really quite been made, and it was just kind of there. And someone at Microsoft, was it Ballmer? Someone at Microsoft wasn't a big fan, and all the networking standards were trying to emerge, and everything was done in waterfall programming, and AI was cool. This was the so-called second wave of AI. It was cool. Then 15 years later, the ASPs have started to turn to software as a service and web services and that sort of thing. Client server didn't really turn into SOA. That's not a direct comparison, but service-oriented architecture started to emerge as a way of thinking, except in the Netherlands, where SOA actually means STD. It translates as STD. So whenever you would say SOA in front of someone from the Netherlands, they would laugh. So I don't know what they use, but that came out. Automation started to rear its ugly head in service management. The idea was some of these things are repetitive and can be done better and better. Elastic and fabric computing started to emerge. The idea of networks becoming more complex and more granular, I guess you'd say, was starting to emerge. And people started thinking on web scale, grid software. And the databases started to be thrown into the cloud, and the whole idea of NoSQL started to come, not only SQL started to come out, and there was a lot of stuff going on in 2009. It was only 10 years ago, but 10 years ago, the iPhone was just introduced, 10 or 11, so that hadn't taken over the world yet. But a lot of this really sort of grid complex thinking was starting to emerge because the idea was you could either virtualize stuff locally and start using the 85% of capacity that you weren't using on your own machines, or you could farm it out to a services provider and have them do this virtualization, or even more radical, you could start going out to third parties such as Rackspace, and then Amazon decided to get in the business. I don't know if they'll ever be any good at it. And then there were cloud standards and then bigger waterfalls. So in the context of all this and truly revolutionary thinking going on at Amazon, there was still a resistance a lot of times. The idea of truly becoming agile wasn't really that important, as I recall, 10 years ago. And languages became very cool. So now, I think there's still COBOL programmers. We know that there's Java language programmers. There's this thing called JavaScript and this thing called JSON that we heard about yesterday. In a lot of families of scripting languages, there's the 3 Ps. And then when Cloud Foundry came out, Golang. And I found a list of the top 10 languages still dominate, but there's probably 500, sort of like in the world. You think there's 180 countries in the world, so maybe there's 180 languages. There's actually probably 25,000 or something like that. I know my wife's from a place in Asia where the language changes every 20 miles still, and 20 miles down the road they can't understand one another, so they try to speak English. And languages were really cool. Now we go between 2009 and 2019. 2009 on the left, we just saw those. Now here we are today. So what's cool today? The SAS-PaaS IaaS triplets have kind of turned into cloud-native thinking. And 12, what is it? What's the 12-step? I'm thinking of.
12-factor app.
I've never been to AA. No, the 12-factor 12-factor development, the 12 steps of software development. The first one, software has power over me, and I can't resist it, and I'll never resist it, so I should just stay away from it, is the first step. So all this is starting to come out. People are trying to think in terms of cloud native. They're trying to make this stuff work without lifting and shifting and big adjustments, and they're trying to think in the future so it'll work in the future the same way it does today. And then microservices and containers just bubbled up a few years ago, and I think are still relevant, but there's so much different conversations going on about that. And then, before microservices and containers could actually take hold and take over the world, that we started thinking of serverless and event-driven serverless. And the whole idea goes back to this book about the big switch, which was about thinking of computing resources the same way we think of water and electricity. And it's not quite the same thing, but people have this intuitive notion that they would like to pay for computing services if they're getting them from a third party by the second or by the event. Why do I have to buy an hour at a time? And of course you buy lots of hours and lots of different things, and sometimes you forget about them, and the bills are rather complex. The good news is if you're in enterprise IT and you're dealing with an AWS bill, you've probably been dealing with a cable bill and a cell phone bill for a few years. So you have a good idea of gobbledygook and complexity. The difference is AWS, as far as I know, is not tacking on all sorts of odd taxes and things like that. But the idea, still the idea, is these lights that are blinding us right now, we know what we're paying for them to be on. And when we turn them off, we stop paying electricity. Same thing with the water. And that's intuitively how people are trying to think of computing power resources. So now, as we are thinking of elastic and fabrics, mobility has become enormous. Mobile data is the big mover within enterprise IT anyway. I'll forget about Netflix at home. But with an enterprise IT, mobility and the mobile devices have really taken over. And they create, data is doubling like every 3 years. According to Cisco, we create 28% more data worldwide. And that's a worldwide number, so in your particular location, it may be a lot higher than that. Doubling every 3 years, and 65% of that is mobile. And along with that, we've got the IoT, and there are IoT developments going on. All the sensors that are being put in manufacturing with the so-called IIoT, industrial IoT, there's a lot of sensors being put in. There's a lot of traffic sensors being put in, and they'll send out like 10K messages every 30 seconds, that sort of thing. I've met people who are things. I've met people who had heart procedures and might have pacemakers, and it's sending out signals to make sure everything. Oh, we have a thing.
I got one here.
You might have been the first one that might be who I heard it from first. There are people who are things in the IoT. We have that, and then also, you know, all the fitness stuff that's going on, and your personal fitness, and when you run marathons, and all that stuff is being buzzed up into the cloud, and a lot of stuff. You have to think of your mobile phones, your mobile devices as things as well. This is generating a lot of data, so it's probably a good thing that for the 15 years prior, people were thinking of elasticity and fabrics and grids, because if they hadn't been, it's a good, for once, I think humans got it kind of right. We put in the foundation and the structure before we bombarded it with too much data. This is never going to end. We were in the so-called zettabyte era 2 or 3 years ago. A zettabyte's 1 million petabytes. And I think at some point we just need to start referring to them as numbers. I think a zettabyte's 10 to the 21st, I believe. And I think the next one, the yottabyte, is 10 to the 24th. And it just goes on and on. You have, and then it gets absurd. There's things called a brontobyte, which is either 10 to the 27th or 10 to the 30th. The reality is we're just going to create data until, you know, we're never going to stop. And it's going to be huge amounts. And the engineering is, you know, some of it's turning towards organic. Someday we'll store all of our stuff on fabricated DNA or something like that, which will solve the problem of space, because a yottabyte using hard drives would cover, I read this one time, a yottabyte covering hard drives would cover the state of Massachusetts, which might not be the worst thing in the world, but if you took that yottabyte and put it into solid state storage, it would only fill a pyramid the size of the largest, the Giza, Pyramid of Giza. And we're going to need more. We're going to keep needing more. So that's an issue in itself that's being driven by mobility. Along the way, we've discovered high-performance computing. So not only thinking in web scale, but thinking in massive problems that people are going to try to solve, whether they're epidemiological or whether they're in the areas of physics, or there's just endless, there's a lot of high-performance computing environments that need to stay up with very minimal downtime, and it's a real intense thing that really weren't able to do before. Grid software has turned into edge computing. Edge computing has turned into people telling me there is no edge. It's like the dark side of the moon. There is no dark side. It's all dark. And the same thing with the edge computing. It's not edge. It's edgeless if you're at the edge. I mean, there is no real. It appears to be sometimes that you're at the edge if you have a network that goes out to that place in that data center. But the interactions within the grids are more complex than that. So we're thinking in terms like that. I mentioned NoSQL before, and I didn't spell NoSQL correctly, but hey, you know, I know how to spell coffee correctly. And blockchain came out. I had to put blockchain in there because blockchain is a distributed database. One way of looking at it. And it just came screaming out of nowhere, supposedly. My wife has a t-shirt that says, "I am Satoshi." Got it at a conference. So I told her, God, I hope so, because and we're missing out. So it's still this mysterious phenomenon. We had this conversation yesterday that I tried to keep my brain straight, and I ended up more confused than I was at the beginning. But the reality is, because blockchain is, there's no such one thing. There's a lot of it, and there's a lot of different initiatives going on and different ways of solving the problem. This did not exist 5 years ago, and it certainly did not exist 10 or 25 years ago. And I forgot to mention for Gordon, so subversive open source by 2009 had graduated to disruptive open source. And disruption, apparently disruption is like legitimate. Disruption is not a bug, it's a feature. It's what we all want to be. And I'm thinking, I wish I could go back to third grade when they kept telling me I was disruptive. And say to my dad, no, it's not a bug, it's a feature, Dad. We want to be disruptive. Have you ever read the German guy, that wrote about this? So, for better or worse, so Gordon just wrote a book. He gave it to me last night, and I just didn't get to read it, but I will. And it's all about open source. And we've gotten to the era of corporate open source. Now, 25 years ago, that's like Jerry Rubin selling out. It was just like, oh man, you're selling out to the corporations. And now Microsoft is like a big open source booster. What's going on? What's going on is that people are, on one hand, taking advantage of the idea of a community developing a product instead of a smaller team, even though some of those communities tend to be dominated by smaller teams. And there's a lot of stuff going on with licensing and some recent controversy with that we'd like to hear about. But the overall reality to some people, I guess it's I was just talking with Douglas yesterday about Wavy Gravy at Woodstock because it's the 50th anniversary. I actually wasn't there, I was too young. And he had this line about, if you don't think capitalism is too weird, the guy's got some hot dogs for sale. That's kind of the corporate open source argument in my mind. If you don't think it's too weird, there's actually a lot of good stuff going on, is the idea. And there are dedicated people in communities and really trying to make this work. So sorry the subversive days are gone, but there's a whole generation of young people that don't know and don't care about those days, who are focused on trying to do good for the world through open source. So it's still here and probably stronger than ever. APIs are important. We were talking about cloud standards before. The big thing for the last 3 or 4 years here has been APIs, and once I finally understood exactly what that meant, why you'd want to do it, it's actually very, very powerful. Now, there are companies such as Facebook, for example, that might, and Twitter, sometimes APIs are dual-edged sword. But the whole idea of being able to stitch stuff together, and I have the resources to make it work, is pretty cool. Especially, I do a lot of work on my own, and it's really nice to just go out there and find stuff that I can work with. And unfortunately, you're going to see the result of that work here in a couple of minutes. DevOps, finally, is replacing waterfall, but Ed and everyone that I know have amusing stories about that. It's difficult to change human nature. We try the best that we can. The point is that people are trying to get stuff done faster and more effective and more efficient. And actually, the first time I heard the term was with Google, where they said, we're in perpetual beta. And I thought, great, God. Another thing I wish I would have known a long time ago. Where's your homework? Where's your final project? It's a perpetual beta, man. You know, it's never going to end. And once we start thinking that way, that it's not a problem that the product's not finished, that's good. And a DevOps journey, people talk about them, but there is no end to the journey. And every year there's a new group of young people that are going to come up and get them into that culture. I've met people I was at a conference in Europe where I met people who go to DevOps school. A lot of companies have them. I said, which side do you come from? And this young person looked at me and goes, what do you mean, which side? I'm a DevOps person. I went, wow. Which side are you on, man? DevOps side, what do you think? And they're teaching that from the beginning. I think that's a good thing. That strikes me as being a good thing. Now, that can devolve into arguments about full stack and multi-skilled. And as my wife said one time, multi-skilled sometimes means no skill. You're jack of all trades, master of none. But I don't think DevOps is that way. I think there's a discipline there that people are learning. And at the bottom of my bullet points, here we are in 2019 and AI is cool again. So what goes around comes around. I think this time AI, we have much powerful systems, much more powerful systems to deal with things, and they're trying to solve specific problems. The one that I saw, and I just read about again, was with IBM, and they were working with the company I worked for a while, Altoros, on scanning radiologist scans of cancer, specific type. And the point was not that they could do as good a job as radiologists. They got up to where their results more or less matched radiologists 95% of the time. But the point was that the AI could go through 10,000 scans, 10,000 images in 90 minutes. And so that's a huge amount of data. Human gift for abstraction can take that and go, yes, okay, that's going to improve healthcare. That's the kind of problem I see AI solving. But I'm way behind the times because I'm talking to people here just yesterday and this morning. What they're doing with AI is just like things I would never even think of. Making blockchain smarter. It's like, okay, good. I'm still trying to figure out what a blockchain is. So, as we may think, this is a line in 1945 by Vannevar Bush. We may perish. This is the end of his speech, and I updated. He always used the word man, and so I thought, well, it's really kind of our tools, not man's tools. And so there's a couple little changes, but that's what he said. We may perish in conflict before we wield our tools for true good, before we pound our swords into plowshares. But he thought that it would be unfortunate that if we lost hope. And I tell you, day to day, it's easy to lose hope. So as we may be, 2019, we have the tools. We know the problems. And I really think we do have the tools in a way we never had them before. I alluded to the worldwide wait in 1999 in the 90s. And, there's still some frustrating things, but, we're not flipping dip switches anymore, The stuff is working. We have bandwidth. There are 50 meg connections in developing countries all over the world that have 1/10 of the income of the United States. We're creating green data centers that are a fraction of the size of big data centers, made of biodegradable containers and using different alternative power sources. So we have the tools, I think, today for the first time. And so how can we apply our technology to society in a way that improves our thinking and existence and our being? That's my big question. That's what I wear the suit so you think I'm not crazy, but this is the thing that drives me crazy. And how can we do that? So I've done a little research over the last few years. Douglas, you may want to leave because you've already heard it. So you're going to have to hear it again. I've done some research over the last few years where I take a lot of different factors and I integrate them into formulas. And I don't weigh them, but I use curves and I let Excel do all the work to create numbers out of all these curves that I create. And the whole idea is, I lived in the Philippines for 3 years, okay, and it's not quite what you think it is living in a developing world country. There's a lot of good things going on, and then there's a lot of bad things going on. There's a big gap between rich and poor, a big disparity, and yet there are a lot of positive things happening. Now, I wouldn't expect the IT infrastructure in the Philippines to be equal to that in, say, Japan, which is a much wealthier country, or the United States. But what should I expect? I'm not a fan of all these world rankings that basically tell you that Switzerland is rich and Indonesia is not. We know that. But exactly how are they doing on a relative basis? And if you do that and use the magic of third derivatives, you find the change, the instantaneous change going on. And then you can really kind of see what kind of trajectory these countries may be on, very broadly speaking. And I integrate stuff like income disparity into it, which is going to slow things down. Government corruption, which is probably going to slow things down. So here's a chart. These are some of my magic dots. Now, the developed countries are the blue dots. The emerging countries are the yellow dots, and the least developed countries are the violet dots, the pink dots. And all the dots that are blank are I've got 2 categories in between them all, but these are the 3 we'll focus on. The wealthiest, the ones right in the middle, and the least developed. Going up and down is how uncorrupt they are. So the least corrupt nations are at the top. You see I've highlighted Norway. And the most corrupt nations are at the bottom. This is according to the Perception of Corruptions Index, a publicly available measure. And then going left to right is the enormity of the challenge to get these countries up to speed, how much work really needs to be done to get these countries all to the left, say 20, 25% of the line. And correlation is not causation, but you can see that the more corrupt nations tend to be the ones with the biggest problems. And again, it's not causation. So, real research, you got to dig down and see, well, why is the corruption? How can we address it? My idea is that the ubiquitous use of IT, particularly the mobile stuff, is going to tend to push things in the right direction. That's easy to say until you're on the streets of Manila with soldiers bearing down on you. So it's not that easy, and I've abstracted every country to a dot. But this gives you a general idea of what's going on. And it's interesting to see that the countries in the middle may be still considered fairly corrupt or actually advancing very well. And Bulgaria is one of the countries I've highlighted. Each of these dots is a country, and I've just highlighted a few. And you can see the United States could be doing better. Let's not stand and say, even though we got the red, white, and blue behind us, and think that America's #1 in every possible category, because it ain't. And it bothers me that we should be leading better than we are. We have a more difficult challenge. If you've been to Eastern Europe, or if you've been to Northern Asia, you know how much better the internet is and how faster things are there, and you know that. And we could be doing better. U.S. is a big country. Different regions are different. Bay Area is different than where I live in rural America, but that's the general idea. And I just went the wrong way. So here's the developed countries and how they compare to one another. I've highlighted a few. You can see, I think it's South Africa I've highlighted, which actually still has a really big challenge. And population's being considered here, so the smaller countries have an easier time of it. South Africa's got a lot of people in there. Old Belarus, where there's a lot of development going on. If you're looking for great programmers, Belarus is a country that has them, and it's run by a dictator, but they don't care. Country's working just fine. The thing is, the dictator there doesn't like the dictator in Russia, and so it makes Belarus, generally speaking, a fairly positive environment. Again, not a direct correlation, and these are the least developed countries, and you can see some serious problems in some of them, and Cambodia is a country that is still considered to be fairly corrupt, but they're advancing very, very well, and as an American of a certain age, I like to see that. And then this challenge just shows you, if we're really going to get things right in all of these countries through the application of technology, how much is it going to cost? Left to right, right is more. India, you can see, is way to the right. But more important question is, what's the challenge compared to the size of their economy? So like Uruguay, you could fix it overnight. Not many people there, doesn't have that far to go, and it's not a big percentage of their economy to fix it. Kenya, which is one of the hottest countries right now in terms of IT development, actually is going to require an enormous investment. The interesting thing, it's going to require a higher investment per capita than Sudan, but nobody cares about Sudan. Everybody cares, and Sudan has some problems right now. But everyone cares about Kenya. Nigeria, same thing. People care about Nigeria. But over there, is that Laos? I think, no one cares. So to me, people are people. And if we can look at things numerically rather than emotionally, maybe we can get a handle on the actual specific challenges that these countries face, and I really believe we can fix them. I have the data for 111 countries, and so I could do this for like 60 hours. So anyone has an interest in any specific country, talk to me, because I've got a lot more data. So that's it for me now. Now we've left a little bit of time for other people to talk. Everything I've said, start with Gordon, but then three of you all know each other really well. Just jump in and talk. Did I make any sense? Do we have hope with the technology that we have today? And was there a big thing that I missed?
Yeah, I mean, I really identified with the 2009 to 2019 because I joined Red Hat about 10 years ago. So that slide pretty much describes my life for the last 10 years or so.
Sorry.
I know, there are some flashbacks in there somewhere. But let me talk a little bit to open source and cloud specifically. And I very much identify that with open source. I was also an analyst for about 10 years before I joined Red Hat. And open source was very much this, as you said, subversive thing when I was coming in. Steve Ballmer, Microsoft, Linux is a cancer.
Yes.
They actually had a vice president at one point who Steve Ballmer hired, who was basically a Linux hitman.
Yeah.
And there was, of course, the whole SCO lawsuit that I helped write an expert opinion for and various things like that. But one of the things that strikes me, and actually was kind of one of the core theses of the book I wrote last year, was that open source has really been the sort of the foundation for so much of what's happening. I mean, blockchain's open source, all the tooling around DevOps is open source, a lot of the things around AI are open source, and the list just kind of goes on and on and on from there. Now, that does bring us to some challenges, I think, that relate to cloud today, because there is this issue of open source sustainability. And Roger alluded to some license issues, and licenses are frankly really boring, and I'm not going to spend much time on them. But suffice it to say that open source, one of the things that's fundamentally changed, or at least been recognized about open source in the last, 10 years or so, is that it is to a large degree about a development model. It's not just, it is about user freedoms, it is about user flexibility, and those things are all incredibly important, but it's also about an open source development model, and that requires essentially this virtuous cycle where people using open source contribute back to it. And what is being found today, and this relates to cloud computing, is there's this concern that as more and more computing moves to these big cloud providers, mega cloud providers around the world, the model is changing over incentives to contribute and incentives to work in the open source community. And what's sort of going on with licenses is some people are foolishly, in my view, trying to fix business model problems by, if we only
Did
had
it this way, yeah.
if we only
Right.
had an open source, if only the open source
Outside in.
initiative said this proprietary license is really an open source license, that would fix everything. I think that is a foolish notion.
Now, how's that relating to blockchain? I heard, Renee,
Absolutely. So as many of you know, that IBM is very involved in the Hyperledger project that's hosted by the Linux Foundation. And we're talking about hundreds of customers, hundreds of entities that are part of the Hyperledger project. And what's interesting on the open source side is it became more about experimentation, right? How can we bring new technology together as a community through experiment and through failure, right? And then from there,
I
be able
kind of
to...
missed that point. It's not like we're not at an end point at all. Yeah.
Right,
Yeah, go on.
exactly. And so where we are now is we have had some failures, as an example. You know,
Yeah.
as an example, you may be aware we had Hyperledger Composer, which came out of IBM Hersley, with working with many customers and working with customers to figure out how can we create models that we could create business networks very quickly. And what they found out is what you have been talking about years ago, right, with the IDE, back client, being big, very slow. And so what we are now doing is we have backtracked and said, okay, let's take the best of many of the programming languages, such as VS Code, some other areas, and make it more robust. But let's still keep a lot of that technology in incubator stage, open source, and let the community decide, right? Not let big corporations decide, but the community decide how they want to evolve it and where it goes. So I think, back to your point, you know, on the experimentation, about development, about our ability also to give back. A lot of people don't realize that, you know, the open source is about not just getting, but it's giving back to the community, helping to maintain it, et cetera.
The thing about blockchain, you know, when my wife invented it, it just seemed to come out of nowhere. I mean, is it, but it's not really a separate thing from enterprise IT, right? I mean, is that what you're saying? Then I'm going to let Ed finish up with the summary and how.
But he knows what I'm going to say already. That's why he says that.
He's like, I agree with Renee.
We like think a lot alike.
We think. Don't give this one to Ed.
But it's not a separate thing, it's not a separate thing in your view from everything else going on. Blockchain. It's like part of the.
Oh, absolutely. And, you know, we consider architecture being, and you talked about SOA. If you look at a lot of the blockchain reference architectures, it still has a UI, it has a cloud computing layer, and it has an enterprise layer, right? And so you're absolutely right. It's an evolution of where we've been, but it provides new capabilities where we can establish trust, accountability, transparency, traceability, and so all the things that bring us together as a nation, really, back to your point, the trust level going up in that bar you graphic.
And I'm thinking all my magic dots is the idea that with enough committed people, I'm not looking to overthrow any governments, except possibly the U.S. government. But I'm not.
I
didn't say that. What's that drone doing in here? But positive change through tech. I really want to believe this can happen with committed global communities of people working on these problems throughout the world. And there's venture capital all over the world, which is not the most important thing. But all these things that you see here in Silicon Valley, I'm starting to see all over the world, which I like. However, how are we going to herd all these cats and get all this stuff to work through DevOps? And Ed, you're our appointed expert on that. How are we going to do it?
Well, what I was going to say is, if you listen to what both Gordon and what Renee were talking about, there's some underlying themes involved in there.
Okay.
One of them, I've got an old business architect friend that used to tell me there's only so many patterns in the world. Technologies may change, the patterns still same. As Renee was talking about with blockchain, a lot of the patterns are still the same. But one of the underlying themes that I hear everybody talking about with the open source and with the blockchain, the technology isn't necessarily the challenge. And DevOps, technology isn't the challenge. There's always great technology, there's always great tools. The challenges are the people, process, and the culture. And that, I think, is where we're seeing the big shift over the trends that you saw in open source. Open source took off, it wasn't necessarily a technology thing, it was a culture thing. It was changing the attitudes on how we do things, how we look at it, how we give back into the open source. Blockchain, about as disruptive as you can possibly get. The technology itself, yes, it's complex, but ultimately the challenges are more people, process, and culture in being able to get people to accept, adapt, leverage, and use it. DevOps the same way. Got a friend, Mike Cavus, that goes crazy whenever anybody uses the word DevOps engineer.
The Mad Greek.
DevOps is not a technology. DevOps is a process, it's a culture. I love the description you gave about the training when you asked a person which side did they fall on, and they said, I don't know what you're talking about. That to me is, that training is teaching it right. There is no, the whole purpose of DevOps from a culture perspective was to get rid of the dev guys, throw it over to the wall to the ops guys find a problem, they throw it back at the dev guys, and they point fingers at each other.
Worked on the laptop.
Right. And so tools don't fix that. Tools can make that go faster. I've seen people that claim to be a DevOps shop that they have automated the dev, they've automated the ops, and everybody still throws everything over the wall.
One thing I didn't mention, and I just, didn't have the time, but I will now, is the whole idea in this that IT should be driving the business, or IT. We've been trying to align IT with business goals now for 30 years. Where are we with that?
Still fighting the same battles we were 30 years ago. I mean, 30 years ago, I was saying it's not about the technology, it's about the business. You know, one of my favorite phrases, technology is not the destination, it's the vehicle.
Do business people need to know more about technology? Do technology people need to know more about business? Or is this, I'm as off base as I was with the DevOps young person? I mean,
from my perspective, when I talk to other technologists that I work with and everything, is I put the onus back on the technologists that they need to be able to talk to the business in a language they understand. Because technology is changing so fast, and business is focused on solving their business problems. They can't take the time to have to learn the new technology.
Well, Renee, maybe you can explain to Gordon, who someday will be an IBMer, how things work at IBM, because that company addresses the biggest, most complex enterprises and problems of anybody in the world. And what kind of conversations do you have about that? Business understanding what's going on and technologists understanding why they should work,
Right, and let's just talk about it from the blockchain perspective. What we're learning is that you have to listen to your business owners and to the stakeholders, right? So as an example, we have been talking this week about food safety, right? And how do you get a network of people all the way from the farmer, the distributors, to the retail stores, processing plants, all to work together. And we found out, as an example, back to your point, the farmer doesn't care about what blockchain is.
Surprise, surprise.
I live in the middle of cornfields in the Midwest, and it's where I grew up in that area. And I'm imagining you coming in from IBM and talking to the farmers. You got my deer hat on, blockchain. No, they actually, and that's not fair, because farmers have been using GPS for longer than anybody.
But my point is, they don't really want to know about how blocks are written and how you append blocks to the blockchain, and they don't care about whether data is shared off-chain or on-chain. But what they do is they want a way, so as an example, when there is a food scare, that you don't remove their products.
You're not throwing out the good with the bad. Yeah.
They're now not making money because another farm has
that happens. That happens
here. If you can
here.
solve a problem like that, then they're interested.
All right. I'm going to try. So don't leave. We're about out of time here, and you're watching here live. Don't leave, or leave for 30 seconds and come back. But here, don't leave. Our next presentation is going to follow up on this, and we're going to, I think he's here. We're here, yeah. He's going to talk about changing cloud first into cloud smart, and that's exactly kind of what we're talking about. We've, in the last 25 years, have gotten to where a lot of people, including probably everybody in this room, is talking about being, cloud first, cloud native. How do we make it smart? How do we apply the other technologies that we have to do the best we can with it? So thank you very much. Stay put, and we'll move on to our next session. Thank you.
Thank you.